morning, all of you and everyone. So, distinguished guests, respected colleagues, and dear students and friends. It is a profound honor and even a pleasure to welcome you all as we celebrate the Foundation Day of the Prajakti. Prajakti Research Private Limited. Before that, allow me to introduce myself. I'm Dr. Somnath Saha and serving as a project director and educator at Prajakti Research. With a background in geography and remote sensing and GIS, and over 8 years of experience in remote sensing and GIS, and I have had privilege of contributing to the vision and growth of this remarkable organization. So today, I stand not only as a team member but as a witness to the journey of Prajakti, a journey of purpose and passion and progress. So, uh, today marks not just an anniversary of our organization funding, but a celebration of a shared dream, a dream of empower research, drive innovation, and contribute meaningfully to sustainable development through the geospatial technology and scientific thinking. So the name, you can see that the name Prajakti meaning a technology, symbolize our mission to harness the power of modern tools like GIS and remote sensing, data science, and machine learning, currently AI, to solve the real world problem and challenges from water resources and agriculture and forest, and also smart urban planning. So actually this idea we started in 2024. So we are just a small team, but right now we have a big idea and new thoughts. Today we stand proud as a growing community of the scientists and educators and students and professionals committed to making a difference. That means from others. So basically, our team trying to conduct our different kind of training programs and our internships, our research collaboration with the different kind of project with different kind of companies and testimonies. So what vision and hard work and teamwork can achieve with together. We have also conducted the new media specialized courses and mentor, like different kind of mentors are available here. I will show you name of the mentors. And actually, our team, Sati Prasad Sahu and Chiranjit Singh, and there are various kind of teachers are as a team member in Prajakti. So they have different kind of research, and they also contribute in the climate resilient, data-driven solution. So different kind of sectors we covered right now. So on this Foundation Day, so celebrate achievements we have made so far, and different kind of things. I'm showing few services as Prajakti. Actually, Prajakti mainly focused on the advanced research and remote sensing and data science solutions, as you know that, and recently actually established 2024. And basically, we are working as a climate data and different kind of academic sectors and different kind of trainings and sustainable development goals. Our focus to maintain the sustainable development goals actually. So in this session actually and last 1 year we have covered different kind of themes, just like a geospatial consulting and development. So we are focusing different kind of opportunities to collaborate different kind of companies. So related to the natural resource management and design geospatial dashboard and decision support system and development of spatially intense solution for environmental planning and disaster mitigation. So we are working on it particular section, and if any opportunities with there, we can collaborate with the team. as well as different kind of we offer different kind of short term and long term certificate course, just like remote sensing and GIS, Google Earth Engine. So last 3 to 4 batch already ongoing, and two batch already passed out, and three I think will be the uh, starting from last upcoming months. And Python programming are also including in our courses. Machine learning and geographic data science is also included in particular section. So we are trying to provide our best facilities to provide and different kind of knowledge in different sector. That's geomorphology, water resources, environment and vulnerability, groundwater exploration, and drought assessment. So everywhere we can use this kind of technology. That means without technology we cannot do anything. That's why this kind of technology is most important to know, and also improve our skills actually. And also Projukti provide different kind of internships and totally fully online based internship covering remote sensing and GIS, geomorphology, water resources, agriculture, forestry, environment, urban studies, and climate challenges. These are our sub themes. So already different various kind of mentors are also there and for supporting and guiding. And our main purposes is research and technical support. So we are expertise in creating and maintaining the sophisticated geodatabase and conducting surveys to enhance the livelihoods. Also collaborates with the stakeholder to develop the spatially intensive solution and providing technical assistance to customers and the stakeholders. So these are our main goals actually. So just to meet our core team member. So our founder and director is Dr. Deeprasad Sahu, and he is currently working in water resource engineering and has extensive experience in geospatial analysis and sustainable water management. And me and Chiranjit Singh, Dr. Chiranjit Singh, also our educator, and he uh, in specialized in agriculture and different kind of machine learning and AI and different technologies are handling by Chiranjit Singh. And Aditi Das and Narayan Kayat, Subrato Maiti. So those are our team member, and we are working as a together and build a strong and massive environment. So at that, I will hand over to Subroto. Please take over the session and say something about the foundation day. ঠিক আছে।
Mm, okay. Thank you everybody for joining this event, like Project Research Foundation Day. And today we have published Project Research annual report for 2024 and 2025. And it's a Project Research, it's a research driven organization for sustainable natural resource planning, considering the climate impact under geospatial techniques. And PRPL also aim to address the challenges in different kind of sector like the water resource, agriculture, forestry, climate change, and will focused also future climate scenario, and considering the different kind of global climate model, regional climate model for agriculture and water resource management purpose. And this company actually interface between the industry and government, and, and facilitate different kind of solution. And we focused and the United Nations Sustainable Development Goals, mainly the goal number one, goal and goal number two, mainly the zero and zero hunger and no poverty, and considering the climate action, and considering the water, fresh water, land, and different kind of goal are there. 17 goal are there. We'll focus at least 5 6 goal for future planning and development purpose. And geospatial techniques can be helped to solve this kind of problems over the world. And the project research have two sector. One is the academic, and another is the research R&D sector, research and development sector. And we have provided lots of short-term courses, 6 month courses, 6 month course for basic remote sensing and GIS, 6 month course for and Google Earth Engine, Python, machine learning, and different kind of applications, and like water resource, and like geomorphological mapping, using the remote sensing techniques, and environmental vulnerability, and flood susceptibility, and different kind of groundwater assessment, drought assessment, different kind of applications are there. And anybody can interest this kind of short-term courses, this kind of application courses, and please join our course. And because we have an skill expert, we have an lots of skill expert, 7 8 skill expert in there, and they can help you to solve your whatever you will achieve, and whatever you will target to next year or for and your career. So project research can be support this kind of technology, this kind of geospatial technology, machine learning, Python, Google Earth, in advanced data science like big data analysis, and this kind of thing. And another part is the research and development. And Prajukti research also focused on the water resource, agriculture, and forestry, considering the climate change impact. And it also aim to teach the farmer, landowner, and other stakeholder about innovation and sustainable climate change and natural resource management strategy, and using geospatial platforms. And key highlight of the year, we have done some research work, we have done some officially incorporated and layout foundation, its mission in sustainable research. And we have a geospatial consultancy, and the company launch is the official website, establish the multidisciplinary team, and initiative some pilot project in water resource, agriculture, and forestry, because this kind of three pillar can be help in our society, can be help in our future generation. And we have offer and different kind of QGIS, Google Earth in Python, um, Python based short term courses. And lots of students already join, and they have already completed different kind of short term courses, different kind of application courses. And and also they have enjoy our course and with our expert. And so our service, different kind of our service are there. uh, Dr. Somnath already told you. And different kind of service are there, different kind of research project. We can focus the regional disaster management, we can focus agriculture, water management, forest resource management. And we can help the creating and maintain and sophisticated geodatabase, and different kind of geodatabase. And we can offer technical help to customer and stakeholder. And we can arrange different kind of conference, different kind of short event. And we can collaborate any kind of organizations, like different kind of corporate, different government organization, research organization, NGO. And we have provide different types of short term courses. So and different kind of specific research area also there in Projukti Research Private Limited, and mainly the issue in water scarcity. Because this kind of problem facing the over the world. And in India we can see that mainly the two scenario we can see, North India and South India. Because some South India we can see the different kind of water resource scenario, considering the climate change impact. And also issue the water quality, surface water, as well as groundwater quality. And geospatial techniques can be solved this kind of problem, and this kind of interface in water transfer, and this kind of and advanced technology. And considering the artificial intelligence also can be solve this kind of problem. And different kind of modeling, different kind of hydrological modeling, groundwater modeling, and climate change modeling, and can be solved this kind of problems. And This is the sustainable water specific research area there. This is the agriculture management specific research area there. The agriculture forecasting, agriculture biodiversity, and different kind of agroforestry, crop protection, crop yield, crop gap mapping, and different kind of sustainable agriculture practices. And we'll will also focus and sustainable development and climate change, considering the effect in agriculture and reducing the future climate conditions and different industrial pollutions, health threat, and different kind of sustainable urban management. It's a very important part in our society. And urban flood also there, land use planning, urban strategy, and urban housing and urban conservation, and different kind of research area we have already done and will focus in next year. And sustainable forest resource management and different kind of expert are there, different kind of researcher already work with our company, and they have already completed the short term courses. They have already completed an internship for forest research, for agriculture, for considering the climate change impact using geospatial techniques. And different kind of our team are there. And it's a skill defined kind of skill is team defined kind of background, and like water resource, agri economics, agriculture, hyperspectral, microwave, different kind of and expert are there. So we can provide different kind of short-term courses. We can solve and define kind of a challenging research project. And we can establish and we can develop different kind of AI based tools, and considering the different kind of dashboard or IoT technology agriculture system. So and the different kind of course are there. And short term courses, long term courses are there, advanced courses are there, application courses are there. And looking ahead vision for the next year, because it's a expand it research portfolio. And by initiating the large scale and impact driving project in water resource planning, agricultural sustainability, forest resource management, and also plan to strengthen the collaboration with academic institution or government agency or industry partner, will enhance the our capacity building. And also focus the geospatial platform AI based tools to support the evidence based decision making system under GIS platforms. And also focus the different kind of advanced training and outreach program to build capacity our young professional, and contribute actively national and global sustainable goals. And we have already published different kind of research work in international domain, like the forest prediction, forest above ground biomass using the SAR technology, SAR imagery. And we have already published the machine learning techniques and for the rice crop disease identification in eastern India. And also published the soil quality index prediction using stack hybrid machine learning techniques, considering the different kind of biophysical parameters. We have already published optimizing water management and climate resilient agriculture in Tarakeswar Gondeswari River Basin in West Bengal. And also we have published the flood assessment. It's a very important part in our society. Advanced flood risk assessment also we have done. And this kind of this kind of research already we have done. And we have and will target different kind of research for next year 2025. And yeah, and international book chapter also there. So we can publish any kind of research to in international or national journals, international national book chapters. And this kind of capability we have. So and the different kind of student and different kind of from different kind of organization, and already join these short term courses for application of Google Earth Engine, and application of short term courses, 6 month remote sensing and GIS courses are there. So some student have completed the internship for different kind of research topic on spatiotemporal overview Sagor Mousumi and Gromer Island of Sundarban. and some students have completed the crop growth monitoring and also pulse cultivation in West Bengal, and some student also ITC Netherlands, one of the student ITC from ITC Netherlands, they have completed the uh, modeling for the hydraulical modeling for the stream flow estimation in Sakkar River Basin using the soil and water assessment tools SWAT model. It's a semi-distributed hydraulical model. So this is our annual report. We have published today. We have published this report, and after 2 3 days, you can download, and you can download our annual report from our official website, and we can and I'll focus some specific research domain like pulse suitability mapping, pulse suitability marking, considering the different kind of um, the biophysical parameter, different kind of soil parameter in rice fallow region in east and eight district in West Bengal, like the Murshidabad, Birbhum, east west Bardwan, and Purulia, Bakura, and Purulia, Bakura, Jhargram, West Midnapur. We have already done this kind of excellent research and prediction of pulse suitability in rice fallow area. And using the machine learning techniques, we have different kind of advanced machine learning models like RF, MR, different kind of considering the different kind of global climate model data, regional climate model data to identify the pulse suitability, site suitability location for the pulse suitability in eastern India. It's a very good research because because agriculture and we have also done advanced prediction of rice yield gap under climate uncertainty using different kind of machine learning techniques and in East India, and considering the eight district and we can see the very high rice yield gap, mainly the Birbhum, Bakura, and some part of the Jhargram and West Minapur also there. We have done this kind of excellent research for agriculture sustainability, for agriculture diversification purpose, and we, we have done also some climate resilience strategy for the sustainable groundwater management purpose, and we have predict and sustainable groundwater level, considering the different kind of parameters, and different kind of parameter in Tarapasar Gondeswari River Basin, different kind of parameter in elevation, soil, and land use, NDVI, and different kind of vegetation indices are there, and we have considering different kind of parameter from soil, different kind of soil quality parameter also there, and to predict the and different kind of rainfall climate parameter also consider, like rainfall, temperature, relative humidity, solar radiation, wind speed, and to generate the groundwater level. And in Mohanodi River Basin, it's a Mohanodi River Basin in Odisha, and after that we have integrated the different kind of water resource data like GRACE data, gravity anomaly and climate experiment data, to integrate it and to generate the different kind of strategy, sustainable strategy for groundwater management purpose. And we have already done in 2024, and through the Project Research Private Limited, and we have done the urban surface water quality mapping in Howrah Municipal Corporation, considering the different kind of pond are there in different, and we have already predict the water surface water quality scenario, and in present, and also we can and generate the 2030 scenario, considering the different kind of climatic parameters. And this kind of research can be help this kind of research and can be help can be help sustainable urban planning and purpose. And machine learning techniques can be help this this kind of solution, this kind of, and geospatial technology also can be help this kind of solution, because geospatial techniques and machine learning can be integrated to solve the urban surface water quality scenario in urban, in different kind of cities like the Kolkata, like Howrah, like Durgapur, Siliguri, and Holdia, because this kind of city surface water quality problems. And so we are also looking the with different kind of collaborating research in different kind of organization. Anybody interest to join with our company, and we can collaborate different kind of agriculture related project, different kind of water resource related project, different kind of forestry, and also flood. It's a real time estimation purpose, flood risk assessment. And it's a Mahananda River Basin in West Bengal. In the Mahananda River Basin actually covered by the North Bengal, like and Jalpaiguri, Siliguri, and Darjeeling, Dinajpur, Malda, and so we have already done the flood risk assessment considering the different kind of hydrological parameter, different kind of socio in economic parameters, and different kind of climatic parameters, and using the stack high stack machine learning technique, and also using the transfer learning techniques to generate flood susceptibility mapping. And after that we have classified the flood susceptibility mapping in different kind of 4 5 classes, like the high susceptibility, low susceptibility, medium susceptibility. So this kind of work already we have done. So Projukti research can be solve any kind of geospatial and machine learning related problem. And to solve mainly we have focused on sustainable development goals, 17 sustainable united nation 17 sustainable goals, mainly focused on the zero hunger, no poverty, fresh water, and climate change, and and mainly the natural resource management, because agriculture, water, and forestry is a three pillar to our society, and we can solve this kind of problem for future generation purpose, future sustainable development purpose. And thank you everybody for joining this event. And we are also looking collaborative research work, and we have also provide different kind of short term courses. And I think we'll focus on the advanced technology in 2025 to sustainable development purpose. Thank you everybody for joining this event. Thank you.
My screen is visible to all.
Yes, yes.
Okay. Thank you, everyone. Uh, Actually, the PRPL is our family, and now today is our PRPL's anniversary. But our company's age is too young, so that's why it's the first only 1 year. Just we are fast away, and even during in short span of time, so I guided two a student for internship. One is Anandita, and another is Balaji Gopal Krishnan Balamurgan. He's from Netherlands also. And modeling surface water runoff dynamics in Sakar River basins using SWAT model. And another is a comprehensive evolutions of seasonal ecosystem quality variability using open source Earth observation data. So today I will discuss about these topics also, because the open source data is very important to all. Because suppose I am applying in our research, so very high quality, heavy quality research, but it is not easy to all. Sometimes people are not can easily download it also. So that's why the open source data is also important. And you all the know about the ecosystem's quality in its regional impact, global impact, and national impact also. So we are not discuss about that things also. We are discuss about only the topic on only the methodology purpose, and how can I easily handle this scenario. So we can discuss about it. So there in these topics, so I have objectives. First objective to analyze a seasonal ecosystem quality by using open source Earth observation data, and second is identify the trend of seasonal quality, and third is delineation. Also, we all are know place of Earth observation data like VCI, TCI. So there we can't know BTI because in especially in Sundarban area, so many changes in recent scenarios there because uh, there is a very cyclone prone area also and very eco-sensitive area also. So that's why we are analyzing the several kinds of parameter are using not only the single year, using analyzing the several suppose in pre-monsoon period also, post-monsoon periods also, or also long-term data like 10-year data also. We are using also 10-year data. So we are using like first we utilize NDVI of the whole year and last 10-year data, and we convert it in a VCI like, and we analyze the BT also, and that converted in a TCI also, and we analyze also water condition, and we converted in a water condition index also. So the one important is that suppose if I using the NDVI and VCI BT, because I'm using NDVI, and NDVI's value is normalized value 0 to 1, and but BT value is a more also 1 from the 100 also maybe sometime, and sometime it's a 30 degrees Celsius, sometimes 20 degrees Celsius maybe. So if I using these factors in our modeling, so it can be hamper for our model. That's why we just normalize all those factors. But the statistical method, normalization methods is also there, but we are using only conventional normalization method. That's why we converted vegetation condition in vegetation health index to vegetation condition index, and BT is converted into temperature condition index, and NNWI converted in some vegetation health index also converted, and water condition index also converted, and salinity condition index also converted. And after that, second things is that the most important things is the sampling, because there is no too much data. Without too much data and without proper formulated any prominent in this particular area. So there we are, as you always heard about that, and we utilize that formula here because pixels is there. So we are using that Twilight trees data is 30-meter resolutions. The whole cover, how many pixels under the 30-meter under the whole study area, that converted that utilize this total number of samples in sampling purpose. So after that, we use the uh, multi-component analysis, and then we analyze the seasonal means ecological quality index, ecosystem quality index in pre-monsoon and post-monsoon also 2022 to 2023, and there. So,
Yes, yes, you are audible.
hello, am I
Continue. Yes.
actually some network glitch is there also, so I don't know which place my internet is blocked, that I want to know. Again I will restart. Hello, Sona sir.
Yes, please share your screen.
Oh, actually, which part I forget actually.
Okay, last
I don't
eight.
know.
Now eight numbers.
This
Eight.
one,
Eight.
this one.
Yes.
Okay. So all of the factors. So utilizing all of the factors final 2014, 2020, 2015, 2023, and using all the modeling. So we analyze and pre-monsoon, considering pre-monsoon and post-monsoon also, we are utilize the eco-sensitive zone. So there mainly is all of the statistical modeling. But there the main things is we are incorporate in a all statistical modeling, mean Excel based modeling in a also geospatial modeling like uh, simple moving average. Simple moving average is it's a one type of graph we can say. But now with the simple moving average we have converted in a also geospatially and also man-candle result also we have also incorporated in a also geospatial analysis. Now see this is the ecological quality average ecological quality index of pre-monsoon period, and this is the ecological quality index of the post-monsoon period, and this is the SMI trend of pre-monsoon period, and this is the SMI trend of post-monsoon period, and this is the man-candle trend of pre-monsoon period, and this is the man-candle test of post-monsoon period. So we can analyze suppose our ecological sensitive ecological quality index, the current ecological quality index is there, and based on the previous analysis analytical data our condition based on this is the our actually the best, and we are seeing this is our current scenario. So we can adopt and we can also explore the better edge using that visualizations also. Now see this is the average. I can just also zoom these things also. This is the average. So 2023 to 2023, this green are the ecological quality index and SMI is the uh, simple moving average conditions of the monsoon period, and this is the post monsoon period. So see the most of the 2018 most of the 2018 very bad condition test. Sir, our so the result is in a pin monsoon period minus 0.004%, 0.004 point is degraded every year. Ecological quality index is degraded, and in also post monsoon minus 0.001 one index value is also degraded for post monsoon year per year, a post monsoon period per year. So this is our so final eco sensitive zone also. So there you can see the very high eco sensitive zone is very less in this area. So only the green portions or the very eco sensitive zones, very high eco sensitive zones, and zone and very high eco the peoples are migrated from the different place to also their this particular Sagar Islands Iceland also. So there is so many centers is also there. So we need better care for these eco-sensitive zones to formulate so eco-sensitive for eco-sensitive zones also. Okay. So this is our final results, and if you have any questions, you can ask me also. Because time is very less. Hello. Hello.
Yes, yes, you are audible.
Yeah, yeah.
Hello, audience. If any kind of questions related to
Any
this
kind of
topic,
questions you can ask. Any kind of questions regarding the uh, research also, and regarding our companies also. Any kind of questions. If you want to ask, you can. It's free to all. You can ask anything.
okay. Thank you, Subrata. I will invite to our next
speaker,
Yeah.
Ranjit Singh, please hand over to you. Please,
Am I
Chiranjit.
speaking? Yeah. Subhrata is stop your presenting.
And one things, this is the actually this work is actually I am just only guide. Okay, but this work who converted in a matlab, just thinking and real also. The Anandita Singh is our one of our students also in Payukta Research Private Limited, and he's a of internship students of us also. So he did that.
Yes, Subhrata, so it is nice presentation. So audience, my screen is clearly movable. My slide is clearly movable. Anyone? Just,
Dada, is it's visible clearly.
yeah. So, good afternoon to all. So, myself is Dr. Chintu Singh. So, actually, I'm a special educator in the Project Research Private Limited. So, it is my pleasure to give me the opportunity presenting this my papers, high throughput soil nutrient estimations via visible near infrared reflection spectroscopy integrating the PLSR, SDMR, and Sentinel-2. So this research is basically collaborating research and done through the Project Research Private Limited and also Vishwavarthi Department of Agriculture and Engineering and IT in Food and Agriculture Engineering. So my presentation is basically divided in the introduction and problem statement, objectives, methodology, data sets, results, discussion, and conclusion. So we are also know that agriculture is the backbone of our country and 14% in GDP is coming from the agriculture sector. But in the recent times in population explosions, industrializations and climate change and negative impact for the future food security. So in this way, digital soil mappings through the precision agriculture adaptation is the most promising technique for the better enhancement and doubling farmers' incomes yield from more suitable as well as the new dimension also added. We also know that remote sensing technique is the most promising technique in non-destructive near real time estimating from the soil properties both for the small and large scale, the high efficiency and rapid data. So in this way, in the recent times, also in the real-time monitoring for the nutrients analysis through the soil spectroscopy, visible near infrared is the most promising techniques for the quick judgment and soil nutrient status in nutrient. So here is my objectives and motivate to, especially in the two objectives, to estimate the major soil nutrients such as the NPK, nitrogen, phosphorus, potassium, soil pH, organic carbon, electrical conductivity, zinc, sand, silt, clay through the lab-based in situ visible near infrared spectroscopy as well as the traditional estimations for the soil nutrients in the particular in the field. Also carry out the prediction through the two machine learning methods, namely partial least square regressions and superficial machine regression. So next objective we also validate in the particular remote sensing data also incorporated how to estimate the soil suitability map in the particular in the regions using for the hydrologist data in image multi particular regions. So here is my study area. It's located in basically the Hooghly district in the Tarkeswar blocks because I chose this study area is the most promising agriculture intensity is the most high because this area have in the Kharif seasons is the Kharif rice and the Rabi season the potato is the most promising two triple crops as well as the cash crop in the study regions. So I choose these regions basically collected the 200 soil samples were directly collected from the field base using for the random sampling method. In each of the quadrant, each of the plot divided into 5 quadrants and then averaging each of the sample, the geotagging in the GPS. All of the data collected in the 0 to 30 centimeter depth using for the spatial agro systems 2021 to 2023, basically in the post-harvesting period. Then this data also acquisitions to the in the traditional way, in situ lab-based experiment, as well as the parallel, I also estimated the reflectance of the particular soil nutrients in the soil sample using for the ASD skill spec, potable spectrometer. Here is the details methodology. First, we collected the soil samples, then we see soil samples using for measure and estimating in the lab. In the soil pH, electrical conductivity, organic carbon, nitrogen, phosphorus, zinc, and zinc, as well as the using for each of the soil reflectance, each of the soil sample. Also incorporating the three most principal component 1, principal component 2, principal component 3. And that part I also collected in the satellite acquisitions mode in the particular in the depth in the 9 bands in the B2 in the B2. In all the particular input parameters using for the correlations, using for the biology techniques, in each of the window is 10 meter by 10 meter, allowed with the 10 meter centimeter resolution centimeter. Then I am also using for the all the matrix prediction, using for the creasing semi-variable analysis. Then I also checking the then apply the miscellaneous and validations of all this data for training and testing, 70% for training testing. Then I also do some making purpose and policy recommendations, all these things. High fertility and moderate fertility. Then take a recommendations to give the report to the primary target. Then in the other part, in the when we reprocessing all the data, I actually using for the unscrambled the particular software, all the soil reflectance car also using for the processing, first processing the statistic in the first derivative and second derivative. Then using for the RBS and the noise removal, using for the multi-split scatter and noise. Then all the model validator using for this performance metric, just as the residual prediction revisions and quarter rates using for the RMS. Next, I also using for the Sentinel-2 image data, Cloud3 data. So all this data be processed by the Snap software. And I also checking for the data cloud flag 0.5, then filtering all the particular image into particular state allied with the survey. Then I also using for the tenfold cross validations method because I also checking 1 to 10 each of the fold classification, also checking the accuracy. But in my case, is the tenfold is suitable for my results. Okay. Then I also using for the total 12 parameters. Okay. First is visible narrow inference, and third is in the 3 component is in principal component 1 and principal component 3. Then our target variables is the traditional laboratory measure base each of the soil. So next, here is the details, descriptive statistics, all of the soil parameters. Basically, creating the 2 sets of the data in the calibrations and the validations data. Basically, in the started area, the mean value of the soil pH is 4.93, as well as the organic carbon percentage is 0.48%. Nitrogen, potassium, phosphorus, zinc, all soil units are ppm parts per million. Nitrogen is 4.56 ppm in the average of the start area, as well as the sunset play in the details descriptive statistics of the start. Here is all the data pre-processing steps using for the lab base, and first we also checking the 3 principal component analysis because in my case 90% data covariance of the variability of the data stored in the PC1, PC2, 90%, and others in the principal 3 components is the least. In the particular detecting the soil reflectance in the particular nutrients, I also saw in my results also showing that the particular wavelength, just like in the 409, 444, 591, 592 nanometer for the organic carbon, as well as the 430 5 nanometer for the phosphorus and 462 nanometer for the potassium and the 580 nanometer for the zinc, as well as the 492, 565 and 632 for the pH. Next, I also checking my results using for the first derivative and the second derivative. So there is the interesting. So first derivative here is the result showing the organic carbon reaches the highest mass carbon in the compared to the second derivative, as well as the phosphorus and zinc is the highest validation results compared to the second derivative. So in my case, first derivative is the most choiceful for the further processing all the output in the results robust noise. Next is similar way also checking my results by the support vector machine regression technique. Similar way in the organic carbon is the most suitable results is achieved at least in the 80% compared to the second derivative as well as the phosphorus potassium. That is the my coefficient latent factor all of the partial square regression models. Basically pH and EC in the second derivative Savage equally and EC is the most suitable in my case. Our results according to our results as well as the first derivative OC to play is the first derivative in the Savage equally is the most. And here I am using for the latent covariant factor is 1 to 7 and each of the calculated beta coefficients is particular in the soil matrix. Next, statistical semi-waveform analysis using for the phasing analysis. So nitrogen the potassium is the best for my case in the Gaussian models as well as the all the models best fit for the exponential models. As well as the they are using for the spatial dependency, all of the models is checking for the various performance metrics, just like nuggets, partial C and the range as well as that. So here is the my results as well as the PLSR and the SVMR. So pH, ECOC. So I also locate out particularly organic carbon map. So high organic carbon is basically located in the southern regions, in the western regions, and compared to the northern region. So similar way, when I'm checking for the sand clay or any other potassium or phosphorus, so similar trend also showing the in the pH as well as case, showing the various type of the variability which is the most suitable in always the checking in a particular rasters. Okay, this is the particular my target rasters, and there is my final results and checking for the laboratory based results. And next also checking my my model PLSR is image. So in the suitability classes, in the first picture in the first picture of my particular maps, also checking for the in the lower part of the my results is in the dark blue colors is the high suitability and the low grades is unsuitable. So this is the basically in the laboratory base. And next way I am checking my results in the basically in partial square regression method and support vector regression methods. So the high suitable class is located basically southern regions and compared to the northern regions. So farmer to easily rectify also checking the which plot or which area is the best suitable for the particular crops. So farmer can assume that in the low suitable area, taking a different type of
Your
these are conservation agriculture. Yeah.
Shouldn't say your voice is
Hello?
not clear. Is it's possible to clear?
It is okay.
Your voice is issues right now. Okay, please continue.
Yes, yes. So, so basically, my partial square regression methods is 87% is the area is the, as well as the 88% by the support vector regression is the most suitable. So this model is taking basically which area is the not suitable. So farmers can utilize is the better type of the precision agriculture approach, just like in the conservation agriculture. Different type of the crops is a particular region. So the crop suitability of the better crop rotations, as well as the optimum rate of the variable rate of the particular fertilizer the suitability zone in the particular field level scales. So this is the conclusion of the recommendation. So this is strategy extensive and non-destructive understanding technique for analyzing the hashes of the soils, as well as quantifying the particular soil nutrients and the fertilizer. This type of technique also is usable. So best crop rotation and land suitability data, soil mapping, minimal environmental impact, and climate change. This is the most openness, different type of sustainable development tools also achieve this type of technique. So this here in areas identifying the regions on the most promising quickly identify the nutrient deficiency zones and the quality of the fertilizer. So this methodology can be useful for recent type of advancements, different type of the precision agriculture after just like IoT or UV or high resolution the deep learning can also be used for automated analysis and the real-time mapping for the soil nutrient, particular small field scale, the primary and the field scale. So there is a various type of limitations in the studies. Land holding size is not actual size. This effects for the judgments or the segmentation of the particular field, particular plot, as well as the soil moisture and the root, all different type of pesticide rates in the farmers level, which is most challenging to eliminating this type of uniform for better justification. So, thank you. So this is the points in today's research. So you can have any question. Yes. Hello.
Yes, yes. Okay. So I will invite next speaker, Dr. Narayan Kayat. Please share your level.
Yeah. Am I audible and visible?
Yes, both.
Yes, sir.
I am sharing my screen actually. I first introduce my institute details and then I will go into some case study.
Hello. Any questions, participants?
No, there is no question. If any questions, I
Yeah,
will
yeah,
let you know.
yeah. Thank you.
Is my screen is visible to everyone?
Yes, yes, Narayan. Please continue.
Okay. Currently I'm working as a research scientist at Environmental Management Policy Research. This is under the government of Karnataka. So my institute basically under the Forest and Ecology and Environmental Department of Karnataka. My institute basically provided to the policy, climate change related policy and environmental related issue of research and academics basically. And we have also provided capacity building program like lot of environmental and climate change related training program and another research service all are we provided and this is my institute structure. All are first director and director general all are basically uh, IFS officer and under the different department we have different like capacity building program and capacity building department.
Narayan,
Yes.
sorry to interrupt you.
Uh,
If you sharing your PPT
yeah.
and not showing here.
Okay. Just 1 minute. Yes.
Yes.
Yes. This is my institute structure. Different department is there. I am working actually climate change department under climate change short-lived climate air quality section also there, and we also DST lab also and lot of different instrument is there. DST console lab also, and we And this is the most of the climate change related. We have different project actually, from international project as well as the DST funded project, and also ISC Bangalore some project, and government of Karnataka some project. Our section actually currently running different project like short-lived climate pollutant for state of Karnataka. It is sponsored by Sequa Climate, and another also identify the emission hotspot and developing high resolution emission inventory using drone technology, and another also emission reduction and energy economy. This project also sponsored by IIT Hyderabad, and another also project is ongoing. Some output is our project SLCP. We are monitoring the SLCP core parameter, black carbon, methane, and tropospheric ozone. And we are also preparing IPC guideline methodology for develop high resolution 1 by 1 kilometer emission inventory. And also we are using satellite data to fit the model for surface concentration mapping for every, and also we are using WRFK model for like future forecasting or every like 1 year. And also we try to the validated our Tesson based data like pollution control board Tesson based data. Those work is actually ongoing. Another, we are also collaborate to the ISC Bangalore and NIAS. First time we are developed high resolution 4 by 4 kilometer emission inventory PM2 and PM10 using drone technology. Another project we have also emission reduction and energy economic of electric vehicle. This project basically collaborate with IIT Hyderabad. So we are after destroy the battery. So how emission also coming. So we try to the like pilot project run for Bangalore as well as Hyderabad to develop the methodology after destroy the battery. How can we can remove the emission also. So those project are essentially running. So I'm going to the actually one slide. So SLCB project. So much more case study. Is my screen is visible to everyone?
Yes, yes. Yes, yes. Yes.
Yes. So we also running on international project like implementation of short-lived climate pollutant in Karnataka. This project sponsored by Sequa Climate US. And why we are required short-lived climate parameter monitoring? After CO2, it is very harmful, but it is moving to the atmosphere only sometime short time, basically day to year. But it is highly effect to the short-lived parameter. Short-lived parameter basically black carbon, tropospheric ozone, and methane and hydrofluorocarbon. So our goal is reduce to the emission by 2030 and 50, and also avoid the climate change related issue like health issue and food security, and another like agriculture productivity reduce. All are our source actually. This is all our SLCB source. You know, lot of sources like different transport and agriculture burning and industry, biomass burning, and construction, power plant, and all are basically provided like lot of emission. Climate change, you know, all the temperature increase and rainfall pattern change local, all that happen to the air pollution. And health impact, you know, all that tropospheric ozone is very harmful to cancer and other skin disease. And also you can check also like World Health Organization report the every year like lot of million of death due to the air pollution. And agriculture impact, you can agriculture impact, you know, the productivity is losses day by day due to the air pollution. And economic loss, you know, obviously agriculture productivity loss, economic losses is there. So that's why we monitor the particular short-lived parameter and reduce to pollution level. So what is the black carbon? Black carbon is the part of the PM2.5. It is very small material, but it is very effect to the after carbon dioxide. So highly effect to the human and vegetation and climate. And those are the sources. You can show the lot of sources of different sources is there. So in Karnataka, we are using like IP different emission inventory we prepare. So different sector, how much a contributor of the black carbon, you can see it. This is road transport and industry and stubble burning and forest fire, all are different sources. We calculated the different year data set, 2005, 10 and 15, 20 and 22 data set. And coming to the like one sector like black carbon emission inventory from industry sector in Karnataka, we also developed the emission inventory 1 by 1 kilometer emission inventory from Karnataka from industry sector. So lot of sector is subsector is there: Blickin, thermal power, sugarcane industry, and cement factory and steel industry. You can see this is the overall data, black carbon emission. Pink color basically highest emission. This is unit is the ton per year per gig. This is based on the GIS based model. Lot of data is required like fuel consumption, emission factor, facial data also located of industry, and all the data is required, and you can put it to the model fit and develop your emission inventory. So you can see this is the Karnataka map, and I just zoom this Bangalore area. You can see the pink color, basically highest contributor of the black carbon from industry area. This is the industry wise. You can see the pie graph, and which industry is the highest contributor in Karnataka. You can see coal. Coal is the almost like 53%, for 32%, and another also like LPG and solid diesel or different. This is the percentage also. And also we are generated district wise emission, which district is the highest contributor and which district is the which district low contributor of the black carbon from industry sector. So you can see this is the all are the district we put it industry wise. You can see this is the Ramanagar and Mysore and another district is the highest contributor of the black carbon, and Bangalore urban also from industry sector. I'm coming to the another subsector, black carbon emission inventory from Brickin sector. So first we have identified the where is the Brickin location. That's why we are using machine learning method to identification the Brickin location based on the satellite data. And after we have identified like 3,000 plus Brickin location, and also matches to the our Google Earth high resolution image. And after identify the Brickin location, we have a lot of data also required like productivity data and annual productivity and emission factor of like Brickin area. Then we can develop the emission inventory. You can see this is the black carbon emission inventory. I just focus one district is the Kolar district. Red pixel, you can see this is the highest black carbon emission, and because of those areas they situated a lot of Brickin, like 2-3 Brickin, also area also high, also productivity like Brickin production also high. Based on our analysis, you can see this like in Karnataka, like Kolar, Shivamunga, all our district is the highest contributor of Brickin. After coming to the Brickin, a lot of analysis part is there, like business as a scenario. If emission is going like similar way, like if we'll go, how much is going by like 2050. We are using LEAP model. LEAP is basically available one software developed by US, and this software we are using for the like annual growth rate and another data for this projection of future projection. You can see this is similar way. It is almost 14 metric ton is coming to by 250, and based on the our emission data, we are preparing which mitigation technology is like suitable for reduce the like black carbon from Brickin sector. So this is the reduction scenario. If we reduce like every year like 5% on 10%, it will become like 250 by 1 metric ton emission will be reduced. After we are also lot of economic analysis like cost benefit analysis. Cost benefit basically provided like which technology is better cost and less amount of emission also produced. So that case we are using like 3 technology, CLAM and zigzag technology. This is Brickin different technology, and so we have identified the VSBK is the technology that we can use for this reduce the black carbon, also cost saving. And another we are also analyzing the health benefit analysis. So it is required for a lot of data set and like health maturity data all are required. So after we are calculated if I like in 2030 currently per person is working is in Brickin area, if economic value is 3,000, and if we reduce it is coming to the like 160 per economic value. So this analysis is required for this the economical for prepare the policy for reduce the emission in Brickin sector. And another also similar we are like emission emission inventory for like thermal power. Also, we collected all our government data and put it to the emission inventory for, and also preparing like similar way business scenario, reduction scenario, and mitigation technology for Karnataka. Similar way, cement industry also done, and sugar cane also. You can see those are the sugarcane location, industry location, and we also collected the sugarcane production data and like baggage data, generation data, and those put it to the model and generated the emission data set. And our data actually like provided to like which district is the highest contributor. You can see this is the Belgavi, Bhagalkot. All district is the highest like BC emission from sugarcane industry. And coming to the another sector, this is the transport black carbon emission inventory from road transport. It is very highly black carbon emission, also related to the death due to the like black carbon in transport. And you can see first we have developed like emission inventory. A lot of data is required, like car count number and fuel consumption and the distance per kilometer, emission factor of different car is different emission factor. So you can see this is the full Karnataka 1 by 1 kilometer emission inventory. I just focus to Bangalore area. You can see red pixel basically 3 or 4 like traffic junction area. So that's why the coming to the highest emission. And also this area is the highly populated area, so that's why the red pixel is coming the highest emission black carbon in Bangalore area. And also we are calculated to the vehicle wise, which vehicle basically highest contributor in Karnataka. You can see this is a truck and lorry 29%, and also tractor is 48% like contributed, and another also different car like two-wheeler, four-wheeler, how much contributed we have calculated. And also we have calculated district wise emission. So you can see this is the this Bangalore urban is the highest contributor of, because of the highest like transport like traffic area is the Bangalore. And also Belgavi and Tumkur and Hassan and Vijaypura and all our district is the highest DC emission from road transport in Karnataka. And similarly, we are calculated like different year for identification the annual growth rate. So you can see this is the different year graph of black carbon emission in Karnataka different district. And also this is the future projection and like different vehicle wise future projection. And this is the all our mitigation technology that we can use for the reduce the black carbon in transport area, like purified filter and electric vehicle, urban transport design, like a lot of green infrastructure, all are required for the mitigation technology for reduce to the black carbon from road transport sector in Karnataka. Similarly, we calculated to the, if we like convert to the diesel engine to like electric vehicle, how much benefit it government is benefit is coming. So we have calculated 2022 and 30 and 50. So those benefit basically per year, per kilometer per year. We have calculated. And similarly we calculated the health benefit analysis. So if I reduce like we reduce to the black carbon in transport sector, how much economic like health benefit is coming, we have calculated. And different projection also we have done. And similar to the another sector, the BC emission inventory for residential and cooking sector. So cooking sector is the residential and cooking sector, 3 sector, LPG and biomass and kerosene. We have calculated different sector emission from black carbon emission from different sector. You can see this is the LPG base Bangalore. I just focused Bangalore area. Pink color is the highest contributor. Based on the model, we put it pink color because this area is the highest population. Also, they are using lot of LPG and they are cooking purpose. So that's why the highest emission is coming. Similarly, we are like mitigation technology and cost benefit analysis and vigilance scenario for preparing for policy making and mitigation technology. And so also black carbon emission inventory we are preparing for agriculture burning. Punjab and Haryana, lot of agriculture burning on produced to the lot of black carbon and PM 2.5 and another parameter. So here is we also use the satellite data and we consider like lot of COPS area and productivity data and diameter factor and different COP also different emission factor. and we develop the 1 by 1 kilometer emission inventory. So you can see this is the all our burning area based on the Modi's satellite data. We have identified the where is the particularly agriculture burning. So this different year you can see this is a map. Particular agriculture burning is happened in Karnataka. Based on the data, we have put it to the model for the emission inventory black carbon. So you can see this is the Kulburgi and Adir and Raichur. All are district is the highest contributor of black carbon emission from agriculture burning. And also we are developed the different year for like identifies the growth rate and also emission growth rate and burning growth rate. That can be used for this fit the model for the future scenario and reduction scenario. And similarly, we are using uncertainty analysis using multi-color simulation model. So this basically provided the your work is uncertainty how much error is coming, because we are using a lot of secondary data and satellite data. Lot of error is coming. This is showing like 31% is error is coming, and this is the mitigation technology. Those technology we can use for the reduce for BC emission from agriculture sector, and this is cost benefit analysis and another health benefit analysis. And coming to the another sector, black carbon emission inventory from forest fire in Karnataka. We are also similarly we identify the where is the forest fire location in Karnataka. So based on the Modi satellite, first we have identified. You can see this is the forest fire location of different year. Also, lot of parameter is required for the emission inventory, like burning efficiency and emission factor. Different forest type is different emission factor, and also average biomass load. All our data is required. Based on the data, we have identified like which district is the highest contributor. You can see Uttar Karnataka. This is Western Ghat part. This is fully forest area, and those area is the highest contributor of the forest fire based emission also. And another this is different pattern also. You can change the different year forest fire pattern emission also. And similarly we are working like different year for identification annual growth rate for put it to the leaf model for future projection. And also this is the uncertainty analysis and mitigation technology, and all our reduction scenario also. And second part, this is all are based on the IPC guideline based and based methodology. And second part, we are also monitoring satellite-based monitoring. So Sentinel, Modi's, and also OMI, a lot of satellites is available. You can directly track your emission every day. Data is available. Sentinel-5 basically provided ESA, European Space Application Center, and they are provided a lot of air quality parameter every day. You can use for your purpose, but this is atmospheric data. You have to put it to the model for convert to the surface level. This is column data set, and a lot of modeling is there. You can convert it your surface level. So satellite, we are also working. Satellite actually directly not provided black carbon. You have to recall a lot of parameter like carbon monoxide, NOx, and AOD parameter for calculated to the black carbon concentration using satellite method. And also a lot of parameter is required like climate parameter is required for convert to the pressure and temperature. Lot of parameter convert to the your surface level concentration. So this is we have first to work like atmospheric level, then we put it to the model for surface level concentration. You can see this is 2021, 22, 23, 24. All are every year we have annual product we have developed for satellite based, and those data we also validated also our station based data monitoring CPCP Central Pollution Board data set. You can see where is the red color is here lot of hotspot area. You can see this is the all our cement industry and a lot of power plant and energy, and Bangalore urban you also know transport area also lot of, that's why is the coming in the hotspot area red pixel. And here is the, you can see this is the Bangalore area. Is the every year they increase the pattern of black carbon concentration. So different seasonal variation is there. And similarly we are working like sector wise satellite based. This is the urban sector, which district is the highest risk area we have identified, urban sector. And also hotspot area and common pixel area. So we are also identifying the 6 year data and where is the common area we have identified. So those area we can for preparation reduce to the emission of those area. And this is another parameter is methane. Methane also greenhouse parameter. You know this is very highly impact to our all our atmosphere, like surface. And we are also calculating methane, like defined by sector, waste sector, energy sector, FLU, agriculture, forest, and other land use. So those are sector we have done. So methane emission inventory from agriculture sector. So agriculture is the three sector is there, like livestock, rice cultivation, and agriculture residue burning. We are combined to the whole data set one sector, one map. You can see this is the methane emission graph here. Which district is the highest contributor of the methane emission in Karnataka, and from agriculture sector. And also we have identified the how much contributor like livestock and rice cultivation and crop residue burning. This is the district wise. Which district is the like Raichur and Belgavi and Adir, Mandia, all are highest methane emission from agriculture sector. Similarly, methane emission inventory from livestock in Karnataka. Livestock also two sector, anti-farmation and manual management. So we are using annual census, census data, like animal census data for develop the emission inventory. So our GIS based data is showing like Belgavi district is the highest contributor. You can see those pixel red pixel area is the highest contributor because those areas they are using lot of livestock based productivity they are generated. And also you can see this is the annual anti-farmation defined by animal waste, which animal highest contributed to the methane. So you can see this is the dairy, like lot of dairy buffalo, all are basically highest contributor of the methane in Karnataka. So after our data is provided, like Belgavi, Tumkur, and Hassan, Vijaypura, and Mandya, all are highest contributor of methane emission in Karnataka from livestock. And also we are preparing like business scenario, reduction scenario, and mitigation technology and mitigation cost. If with those technology can we use and how much cost is required for those technology, and we have calculated for reduction of the methane emission in Karnataka. And similar another sector is the methane emission from paddy cultivation. You know, our agriculture background, lot of paddy cultivation is produced the methane. So we are using like lot of where is the paddy location, and identify satellite database. We have and classify. We also collected the like paddy location data from KGS, Karnataka GIS data set, and put the model. And you can see this is the Raichur and another Adir, and all are district is the highest contributor of the methane emission from paddy cultivation in Karnataka. And similar methane emission inventory from agriculture residual burning. So we are also working like methane emission of agriculture burning, and also methane emission from industrial sector. And another is the methane emission from road transport sector. So all are similar. We are working which technology we have from reduce to the methane from transport sector. We have put it to the technology also. And another sector is the methane emission inventory from waste sector. We are working three sectors: solid waste management, domestic wastewater, and industrial wastewater. So you can see this is the all are solid waste location, dumping location. Based on the our model data is showing location of the pink color, all are highest like methane emission from dumping location based on the production data. And this is the district wise, which district is the highest contributor and lowest contributor. This is the lot of mitigation technology, which technology can reduce to the like methane emission from waste sector actually. And another is the I'm coming to the satellite part, satellite imagery based methane concentration mapping. So it is we are using downscaling method, and basically satellite world is very 100 to 50 kilometer data set. After we have downscaling 1 by 1 kilometer, and we convert it to the surface level, this model based data for surface methane concentration, and also matching to the ground level data. You can see this is red pixel, all are highest methane surface methane basically highest methane concentration. And blue color basically water area, so it is showing low. And another you can see this is the and also where is the highest, you can see lot of agriculture activities. The methane basically like 70% is coming to the agriculture activity. So also agriculture and another industry area, and like farm animal production, all are the methane sources. And those area is the highest due to those sources. And this is the time series analysis. So you can see every year the increase pattern is the methane concentration in Karnataka. Those are the air quality station. We are put it to the air quality station based methane emission. Like you can see this is the time series also. We also 10 analysis and management analysis, how increased trend also analysis part is there. And similar way, working like methane emission sector wise, like lot of this is the agriculture sector, which you can see this is the which district is the highest contributor or which area is methane emission, and you can see Raichur, Kolburgi, and Belgavi, all are district is the highest. And another, I'm coming to the another parameter, essentially tropospheric ozone. Tropospheric ozone, basically two ozone is there, tropospheric ozone and surface ozone. Tropospheric ozone consider 0 to 15 kilometer. After 0 to 30 kilometer is the total ozone. So we are working zero surface level tropospheric ozone 0 to 15 kilometer. It is basically secondary pollutant, but first two parameter is the primary pollutant. So it is basically all our gas are mixing, basically NOx and VOC and heat sunlight are mixing, and it is going to the atmosphere and generated the tropospheric ozone. So it is very harmful to the health problem. You know, all our cancer disease was coming, and this skin disease was coming due to the tropospheric ozone. You can see this is the IPC based data in India. Every year is the tropospheric ozone is increase in India also. So in Karnataka also we are working tropospheric ozone. We are working 3 satellite base. OMI satellite is basically provided NASA, and Mira 2 also, Mira 2 MODIS base and model, and also we are working Sentinel base tropospheric ozone. Lot of modeling part is there, like convert to the surface level and atmospheric surface level and matching to the our ground station data also. And those are the area where is those area Uttar Karnataka, basically this is the coastal area and hilltop area. All our gas are mixing is due to the atmospheric climate condition, moving the atmosphere wind speed. All those area is the highest basically tropospheric in Karnataka. And another parameter is coming to the hydrofluorocarbon. Basically it sources of the all our AC, fridge, refrigerator. You know, you are using home like lot of AC air condition like AC fridge, all are they are produced to the HFC parameter. So this is also considered also greenhouse parameter. It is very highly impact in climate change. And this is sector-wise emission inventory in Karnataka, HFC, lot of domestic and residential and commercial. And this is also defined one sub-sector: supermarket, hypermarket, grocery shop, food, fast food shop, fast food restaurant. There are a lot of use the AC and another refrigerator for produced to the HFC emission. And coming to the result one part, hydrofluorocarbon emission inventory. In Karnataka, you can see this is the Bangalore area. Lot of they are using AC, and those area is the highest contributor. And this is the district wise. Which district is the highest contributor? How much it's coming? HFC we have calculated. And here is a lot of parameter required lot of parameter, leakage factor and AC production data, all are required. And similar way, hydrofluorocarbon emission inventory from commercial refrigerator. Commercial basically lot of supermarket, hypermarket. We are using Google API for extract the where is the location of the particular supermarket, hypermarket, and grocery shop. This is the map of supermarket where red pixel is the supermarket and hypermarket. So after we have put it to the model and extract to the emission inventory, HFC emission, you can see this is the red pixel and yellow pixel are all are high emission HFC emission in Bangalore due to the all are located supermarket and hypermarket location. They are highly produced to the HFC emission. And which district is the highest contributor? You can see Bangalore urban, Dokhin Karnataka, Dokhin and Mysore, and all are district is the highest contributor. And lot of activity we have done, like we have also capacity building program and so awareness program. Lot of webinar, invited talk, internship program, government stakeholder meeting for policy making, and also publication also here. And a lot of meeting of IC Bangalore expert and another government expert. They are expert from those field and making the policy for government to reduce to the emission SLCP emission in Karnataka. And those are the some publication we have done. And those are the solution. Basically, all our policy making and reduce to the government should be take the reduce the pollution and improve the policy to different sector. And future we are also working model based forecasting model for future forecasting. Every year we are using CAMEX model. This is fully numerical model, Linux based model. Lot of 30-year rainfall, temperature data, and meteorological data is required, and emission inventory, physics, chemistry is required this model. And future forecasting, this model actually provided in every hour data future forecasting, and also seasonal and for future estimation. So we can also prepare for this model for the future forecasting and SLC parameter also. Okay, this is from our side for MP side. So I also working like 7 year previous IIT Kharagpur at I with Satish Prasada. So since currently I am working my field actually hyperspectral, my PhD degree and hyperspectral remote sensing. Currently I am working air quality modeling at IIT, and I leading the project actually. I have also some student and they are working different project. Okay, thank you very much for everyone.
Okay, thank you, Narayan. Presentation is nice and informative presentation. So I have request to the Prasad Babu. So can we you say something about the last moments?